Just look at this. This is a little drone. It can do lots of tricks. You can make it, for example, do some flips. If I pull push it forward, it does a forward flip. If I pull it down, it usually does a backward flip. I can go left, or right, and I can go across, which gives it 8 moves. But it's so much fun. You can do lots of things with it. You can even land it in your hand. Now, this little thing is called a Tello. And the thing to me is, it's awesome, but how does it work? What I want to do in the next few months is put together some very short videos on how drones work. We're going to start with this little one, but then I'm going to move on to some other popular drones, a Mavic 2, and some of the Phantom ranges as to how they work. Today we're only going to look at 2 things. In the future we'll look at things like GPS, sensor avoidance, collision avoidance with sensors, how they travel so far, how they're able to come back and automatically land in an emergency at the exact same point they take off. Today we're just going to look at 2 things. The barometer, which checks for air pressure for when it's landing, so that it knows when to calm the engines down or speed them up. And we're going to look at how they keep so steady in the air, and they do. They keep incredibly steady in the air. So there's 2 things we'll look at today. In the notes below, I've listed a series of things that we can look at in the next, I'm going to look at in the next few weeks. So have a look at those. This is a Word document, and some links also to further, so you can go and research it yourself. And all I'm going to say today is I got the information from these links. Now the problem is, when you go to look at how drones work, most of it, 95% of it is just long, very difficult to read technical data. There's no real introductory video out there, which is what I was looking for, to show family and friends how drones work in a very simple way that your next door neighbour can understand. And that's what I hope to do today and in the future. They're only about 5 minutes long. So the first one, about the barometer. The barometer checks air pressure. I'm going to launch this. I used a slide bar that time. And I'm going to lower it a little bit and show you how the barometer works. It's now checking the pressure below it. And if the pressure is significant, the motors will rotate to keep the same level. If I grab the drone and raise it slowly, you'll hear the motors drop. And that's because it thinks it's landed. It's checked the pressure below and it's thought, okay, the pressure below has dropped, I don't need to rev up my motors and to keep airborne. So I'm going to go into a semi-comatose state. If I drop it, it will rev up again. I'll just move it away because there's a little table down there. So I'll drop it, and up it comes. And we'll give it a little bit of help so you can see it. And that's what the barometer does, which is an enormous asset for keeping steady in the air vertically, and for when it lands. When it senses the pressure build up on the ground, it slows down and eventually slows the motors down so it can land very smoothly and safely. And that's awesome. Now I'm going to show you how it remains steady horizontally now. It's got something called an optical flow system. It's got 2 sensors at the bottom. One is flashing red and one is black. One is sending and one is receiving. One is transmitting and one is receiving. It's transmitting to get a picture of the floor. Imagine it as a photograph. Millions of photographs a second. Imagine that. And then it's receiving the picture. So it's keeping in memory a pattern on the floor so that it doesn't move. And by that way, it remains incredibly still. Same as an optical mouse. It uses this optical flow technology, a flow system that's continually taking pictures and receiving pictures to remain steady in the air. And it does, in fact, remain extremely steady. If I bring it down a little bit and try to move it, it won't move. Because it's got this picture on the floor and it's saying, no, you haven't told me how to move, so I'm going to remain steady until you move the stick. When you move the stick, or the imaginary stick, it then moves. And that is an awesome piece of technology. Most drones use that. That system, that optical flow system, to remain steady in the air. Some of the more sophisticated ones also use a sonic one where they send a sonic message to the floor, bounces back so they can get telemetry to see how and where the land lies and where it can keep still. Those two pieces of technology are amazing, but they both demonstrate how your drone keeps so steady in the air, how it lands in the air, how it keeps steady vertically, and how it keeps steady horizontally. Obviously, as we move on to the Mavic and the Phantom 2, the systems become more complex and they become more sophisticated, but they're explainable, and that's what I'm hoping to do. And I hope I explained today how the barometer works and how the optical flow works. So next time we're going to look at GPS system, how the drone talks to all these satellites, which is even more amazing. Comments are very, very welcome, but if you do have sort of comments and contributions, please do so, negative, positive. As long as they're constructive, that's fantastic. I may modify some of the things I've said today based on people's replies. And please do send a link if you've got any links. Again, I've got plenty of technical links. It's ones that really explain in everyday terms to your next door neighbour how a drone works. See you next time.